Mr. Whittle has set me a challenge, which is to explain to him how exactly we make these little videos. So I'm going to do a little geography one for him. Of course I've chosen a physics theme. And we're going to look at what causes tides from a physics perspective. So, without further ado, in order to start to explain tides, we need a little bit of physics, which takes the form of this. That is Newton's equation of gravitation, and it's not as complicated as you might think. This term F here represents the force of gravity. This big G is just how strong gravity is. That is the mass of the moon, and this big M is the mass of the thing the moon's gravity is acting on. This R here is the distance between the moon and the thing its gravity is acting on. So in the case of tides, it's going to be the water on the earth and indeed the earth itself. For the non-mathematicians among you, that means that the larger R becomes, so the further away something is, the smaller the force becomes, and vice versa. The closer you are to the moon, the stronger its gravitational pull is. We're going to need this for the next step. We all know we live on a little blue-green planet called the Earth, and that the moon rotates around the Earth. We also know that there is gravity between the moon and the Earth, and it acts in both directions. So the moon pulls on the Earth and the Earth pulls on the moon, but the bit we're interested in is really the moon pulling on the water that surrounds the Earth, the oceans. So there we go, there's the oceans around the Earth. Now, the oceans on this side of the Earth are closer to the moon, and so it stands to reason that the force of gravity will be a bit larger on them, and that will cause them to bulge out a little bit, be attracted to the moon. Obviously I've accentuated this on the diagram. What you might not realise though is that the oceans on the other side also bulge. Now obviously over here that is further away from the moon and therefore the force is smaller, but the force of the moon on the Earth itself is greater here than it is here, and that has the effect of actually managing to pull the Earth towards the moon like that. So it pulls the Earth away from the ocean on the opposite side of the Earth and leaves the ocean behind, causing the bulge over there. Now that effect is not massively pronounced, so there is something else that's also at work. And for this I'm going to need a new diagram of the Earth and Moon. There we are. You're probably all rather happy with the idea that the Moon rotates around the Earth a bit like that. And you're probably also happy with the idea that as it goes it drags the water around with it. Well, yes, and also there's a little bit more to it, as there always is with anything slightly physicsy. You see, the Moon doesn't just rotate around the Earth. Both the Earth and the Moon rotate around a common centre of gravity, which makes it look a little bit like this. So that's really what's going on. Now, the Earth is actually much more massive than the Moon, so the Earth isn't quite moving around that much. In fact, this common centre of mass is actually a lot closer to the Earth than it is to the Moon. In fact, it's so close to the Earth that it's inside the Earth, and the real rotation looks a little bit more like that. But the point remains, the Earth is still being spun around by the Moon. Now, if you swing a bucket full of water around your head, you will know that something called centrifugal force, the physicists, close your ears now, we know centrifugal force doesn't really exist, but this idea of centrifugal force will throw the water out to the side of the bucket. And I'm doing all of that in inverted commas because the real physicists know that it's not quite how it works. But for everybody else, that's a good enough explanation. So what's being done here is that as the Earth does this spinning around motion, the water is actually being thrown out to the sides at the far side of the Earth. So that's causing an extra little tidal effect. So, in summary, tides are caused because the moon attracts the water on the side of the Earth close to it, and it attracts the Earth, pulling it away from the water on the far side. The Earth and the moon also spin around each other, which causes a slight centrifugal bulge of water on the far side of the Earth. Of course, the water's the thing that moves rather than the Earth, because it can, because it's a liquid. Hopefully that's cleared up some things about tides, and hopefully it will help Mr. Whittle to know just what he can do with explanatory videos.